Like, oh, I get it. Okay, finding side lengths. So good old SOHCAHTOA. So what I'm going to do is write that off to the side so I don't have to think about it, right? Because if you think about it as you do problems, you're taking up your working memory and you're more likely to make mistakes. So we just write it so we can look at how those fractions work. Don't write like SOH horizontally. Write it like that because it's better. Because then you know which one goes on top. So if you get confused between opposite adjacent and, right, so adjacent means next to, right? So Peyton and I are next to one another, right? That's adjacent. If I go like this, now we're opposite of one another, right? So across from is opposite, next to is adjacent. So when we look at this angle right here, 32, what is 11 as it relates to 32? Opposite or adjacent? Opposite. How do you always know which one's the hypotenuse? Across from the 90-degree angle, right? So the hypotenuse longest side across from the 90-degree angle. So given problem number 1 here, which trig ratio am I going to use? Which one? So, ca, or toa? Sine. Good. So sine 32 equals 11 over x. That's why the order of these letters is important, right? Because the 11 has to go on top. How do I solve from here?
Multiply by x.
Cross multiply, right? Multiply by x, same thing. So we get x sine 32 equals 11. And then I divide by sine 32. And I can put that into my calculator. So get your calculator out. Make sure when you get your calculator out that you click on mode. So I'm going to clear all this stuff. I click on mode, which is right next to second. So click mode right here. And then you go down to make sure that you're in degrees, right? Because we're solving problems using degrees as opposed to radians. So make sure you are. Oh, by the way, I had somebody steal one of my calculators, the yellow ones. So please give it back if you stole it. You can borrow a calculator if you need to. So make sure you're in degrees and then get back to the home screen. You click second quit. See the blue above says quit. So second quit to get back there. And then we're going to do 11 divided by sine 32. Okay? You should get 20.8 rounded to tenths. 20.8. Okay, so x equals 20.8. Do I need units? There are no units, right? It doesn't tell me the side length is centimeters. Do you have a question? You're kind of in the middle there, so you could take notes from like, okay. I got a charger plugged in right up here to this thing behind the desk. You can come around. It's like it's not a micro USB, but it's a big one. Let me see. Yeah, that's mine. Yep. Okay. So 20.8, you don't have to put units. If we had like millimeters next to 11, you'd have to put millimeters, right? For solving for an angle measure, then you need the degree symbol. Okay, we good? Try number 2 on your own. Número 2. Uh-oh. Wigging out. Because he bumped this thing. It's very temperamental. It's fully wigging out now. Oh, it's frozen, I think. There we go. $78.4 is the correct answer. Good job. Right? Side lengths.
Mr. Evans?
Yes.
Did you say as the answer?
You good? Let's say we wanted to solve for the hypotenuse. What would you do? Pythagorean theorem, right? If you have two of the side lengths, I'd always do Pythagorean. But whatever, you could do a trig ratio as well. It doesn't really matter. Whatever you prefer. And I wouldn't care if you did it one way or the other. Okay, we're going down to the bottom here. Now we're finding angle measures. So we do inverse sine. The only way to switch places between theta there and x, we say sine inverse, right? So inverse sine of x will give us theta. Same thing with cosine and tan. Inverse cosine of x will give us theta. Inverse tan of x will give us theta. Give you a sec to write that down. Now we look at number 7 here, and what is 18 as it relates to theta? Opposite adjacent or hypotenuse, it is adjacent. And 23 is hypotenuse, so what are we doing? We're doing cosine. I'm going to just put the fraction in the parentheses right away because it saves me a step. So inverse cosine of 18 over 23 is going to give me theta. When you do that in your calculator, you should get theta equals 38.5. You have to put the degrees. Remember, they say up here, round to the 10th of a degree. So make sure you round and round properly. 5 and above, give it a shove. Okay, do number 8 on your own. I'll write the answer up here. Inverse sine. You can check your answer if you're already done. If you're looking for an angle, you always do inverse. That's correct. That's perfect. Well said. Okay. Next one we're going to do is 15. Okay, and we're solving for the whole triangle. So if I look at 15, how are you going to get that missing side length? I'll show you a little trick in the calculator. So in your calculator, you can just subtract this. So I'm going to do, somebody tell me what you get. You get b squared equals, say again? 56.4. 56.4, we agree?
Is that wrong?
That doesn't sound right.
No, it's like
6.24, right? 6.24? Sounded too big. And then we square root that and you get 2 point something? 2.5? Rounded, right? 2.5? Okay. So when they label these triangles, this is little k over here, but it's also JL. So JL is 2.5. If it helps you to write that on the little triangle, write it on the triangle. So then when I solve for K and L, I can use any of the trig ratios, whatever I want, right? So let's say we're solving for K, so we're doing the one up top. I could do opposite over hypotenuse. I could do opposite over adjacent. I could go adjacent over hypotenuse. Totally doesn't matter. Let's do, what do you want to do? Sine, so we'll do opposite over hypotenuse. So we'll go inverse sine of 2.5 over 8. Oops, that was weird. 2.5 over 8. So you hit second sign, 2.5 divided by 8. And we get 18.2 when we do that. Makes sense that that's a little degree too. I don't know if they're always drawn to scale, but this one is. Then now we can go 190, 180 I meant. 180 minus 18.2 plus what? Because we already know 90. And when we subtract that, we should get 71.8. Okay. So we can do Pythagorean theorem to get this one. So 21 squared, 16 plus 22.5 squared. So here's another little trick in your calculator if you want. You don't have to do it this way, but I like doing a bunch of steps in one. Right? So you can just square root that whole thing in your calculator, right? And that will give you what C is. So you can go square root of 21 squared. So you go second, x squared, 21 squared. What was the other number? 22.5? So you can tell that cursor's underneath the radical, so we're good. And we do the square root and we get 21.5. That doesn't seem right. Oh, I forgot the square. It's like something is wrong. So I have to go back in and I can go second insert and put a squared in there. And now it'll work. So 30.8 rounded to the tenths. So DF is 30.8. And then again, you can pick your, I'm going to do tan, inverse tan of 22.5 over 21. Again, you could do any trig ratio because we have all the sides now. So you pick, it doesn't matter. And then inverse tan, so what am I solving for? Opposite, so that's equals D. So angle D equals 47 degrees. I'm just going to plug that in and double check. So second tan, 22.5 divided by 21. Right? 47 rounded to the tenths. Okay? So if that one is 47, what's F? You can do that in your head. 43. Right? So all I'm doing, I know I already have 90, right? So I'm thinking 47 plus what is 90? 47 plus 43 is 90. Right? You could show the step if you need to. If on a test you get that wrong and you don't show any work, you lose more points. So I would just show a ton of work on a test, right? Because every bit of work you show, if you make a little mistake along the way, I'm the kind of grader, most kids really appreciate how I grade, because a lot of times for other math teachers, if you make a mistake early and then carry that mistake throughout the problem, they'll take off a ton of points. I don't do it that way, right? I recognize the fact if you make a mistake early, you say that's 48 because you rounded wrong and then that number's wrong, I'll take 1 point off. I'm not going to take 2 points off because you missed 2 angles. Because if you miss the first one, you're going to miss the second one. So as long as you do the rest of the problem correctly, you get most of the points. Okay, we good on that? So that's the kind of question I would put on a test because it gets everything in there, right? Pythagorean theorem, inverse, like everything we need. Okay, story problem fun. You love it. On to the story problems. Okay, so number 1 there says a fire started at a campsite located 8 miles from the base of a mountain. So I'm going to draw a horizontal line. I have a fire. I have a mountain. Then it says, so 8 miles from the mountain, if the angle of elevation from the fire to the top of the mountain is 14 degrees, that means it's like this. 14 degrees would be like that. There's our 90-degree angle. This little angle right here is 14 degrees. We know the distance from the fire to the mountain is 8. Okay, and we want to know how tall the mountain is, x. Technically little f, but whatever. What do we use? SOHCAHTOA. Tan. Right, so we have tan 14 equals x over 8. When I cross multiply, I get 8 tan 14 equals x. When I do that, I get 2 miles. That's a tall mountain. Rounded, it's 2.0. You can abbreviate miles. Okay, we good? Any questions? You guys are the chill class, like first period's a wild class. You guys are super chill. We're good? Ask questions. I know you're quiet, right? So just please ask if you need to. Okay, man standing 85 meters from the base of the tower. So here's your little dude. He's standing 85 meters from a tower. From a tower. It's not letting me move it, it's fine. And the tower is 200 meters tall. Okay, find the angle of elevation from the ground where the man is standing. So we're looking for here, theta. What am I using? Tan again. So tan inverse, right? When we're finding an angle measure, it's always an inverse tangent of 200 over 85. And that gives us theta. And you should get theta equals 67 degrees. Okay? We'll do 4 next. 4's got a little wrinkle. So if you look at 4 right here, it's in degrees and minutes. So what do I have to divide 18 by? 60. Good. So first thing I got to do is do 18 divided by 60. I'm going to do it over here on 3 just so I have a little more room. And you get 0.3 when you do that. So our degree measure we're going to use in this problem is 48.3 degrees. Okay, so you may have to switch from degree, minute, second form to degree by dividing by 60. What's the next thing you divide by if you have to divide it? 3,600, right? So you divide by 60 first, and if you have the seconds, you divide it by 3,600. So you might want to write that off to the side if you forgot that. For minutes, right? So if it's a single tick mark, let's say it's like 20, you would do 20 divided by 60. And if it's like 32 seconds, then you do 32 divided by 3,600. I find it easier to learn with like the actual example rather than just some weird little rule, right? So if I have the numbers there, then I'm good. All right, so Lana's flying a kite 60 feet above the ground. So there's your little line to the kite, the ground. I'm going to read the rest of the problem though. The angle of elevation from where her hand is holding the string to the top of the kite is 48. So 48.3 goes right there. If her hand is 5 feet above the ground, what is this distance right here? So it's not 60, but it's 55, right? Because she's standing, right? And her hand's holding the little kite string like that, right? So she's 5 feet. So this distance right here is 5 feet. Okay? So we got our 90 right here, and we want to know the length of the string, so we're trying to find that. So we're going to use opposite over hypotenuse, sine. So sine of 48.3 equals 55 over x. So when x is on the bottom, you get x sine 48.3 equals 55. And then you have to divide by sine 48.3. So we can say x equals 55 Just doing that step in my head because I don't have enough room. 48.3. Sine 48.3 is what I meant to write. And then when I divide that, I get x equals 73.7 feet. Right, and that kind of makes sense given our diagram and given the fact that the kite string should be longer than how high the kite is up vertically in the air. All right, we good? We need to pause. You have lots of work time, so you can ask me questions as well if you're confused. Number 6, Sarah's standing 35 feet from the base of a rock wall. Okay, so here's Sarah. Here's the rock wall. She's watching her two sons, Max and John, climb the wall. The angle of elevation to Max is 38 degrees. So this angle, the whole thing is 38. That means Max is up here. Okay, the angle of elevation to John is 27 degrees. So I'm going to draw it in a different color because you too should take notes in a different color. So this angle right here is 27 degrees. How many feet above Max is John? So we can get this whole distance from here to here. We'll call that y. And then we can get this distance x. And then what do I have to do to figure out how? So John's right here. What do I do to get this distance right here? What two things do I have to subtract? Y minus x, right? So in the very end here, I'm going to do y minus x. And that'll tell me how far above Max is when compared to John. So I'm going to do the work over here. So we'll do tan 27. So who are we talking about when we do tan 27? We're getting John's height. So tan 27 equals x over, I forgot to write 35 on my diagram. So the mom is standing 35 feet from the rock wall. So x over 35. So 35 tan 27. That gives us the x value. 35 tan 27 is 17.8. Okay, now we got to figure out y. So we do tan 38 equals y over 35. And when we do 35 tan 38, we get our y value. And then our y value is 27.3. So when I do y minus x, I'm doing 27.3 minus 17.8. What do I get? You can do that in your head, just saying. 9.5. So y minus x is 9.5 feet. So Max is 9.5 feet higher than John, above John. You got to put units on their feet. Okay, I want you to read number 7 and try to do it on your own. Okay, talk amongst yourselves. I'm going to draw the diagram because if you don't get the diagram right, then you're in trouble. Try to draw the picture. And then you can try to draw it if you already drew it. There's my picture.
That's a no.
Right, so you're standing in the middle and the buildings are on opposite sides, right? You look up to the taller building. The bigger angle has to go with the taller building, right? It just makes sense. The smaller angle goes with the shorter building. Okay, building A, building B. So when we set it up, I'll do the X one first. So building A, it is tan 75 equals 464 over X. So it's 464 divided by tan 75. And if you look at these pictures and you're like, I got no chance drawing it, right? So when I put those hard problems on a test, you're just trying to get as many points as you can, right? Because you're not going to get every single problem right. Some of you will, but not many. And then tan 75 equals 321 over Y. We good? I just wrote it weird. I shouldn't write it like that. That makes more sense. So then we get Y equals 321 divided by tan 75. Tan 48, thank you. Is that what you were trying to say? You're like, oh, thank God. Yes, it is tan 48, thank you. Okay, so when we solve for X, we get 17.8. When we solve for Y, we get 27.3. No, we don't. Sorry, I was looking at the wrong answer. My bad. Try that again. When we solve for X, what I meant to say is, I didn't even write it down. What'd you get for X? 124.3. And Y? 289. So 289.02. 413.3. So X plus Y, I just wrote the final answer down. I didn't write the whole thing. 413.3 feet apart. Right? They say how far apart are the buildings? How far apart are the buildings? They're 413.3 feet apart. Okay, so angle of depression. It'll make you feel sad. Okay, from the top of a lighthouse, so we're up here at the top. From the top of the lighthouse, 150 feet above sea level, the angle of depression to a boat is 28 degrees. So this is how the picture should look. So when they talk about angle of depression, that 28 degrees is right there. So you may or may not remember from your geometry way back when. How many people are juniors? Raise your hand. You got to remember geometry. I hate to break it to you. So some teachers teach geometry better than others, and you learn a lot, right? So some teachers don't. So if you have two parallel lines cut by a transversal, we know alternate interior angles are congruent. So this angle right here is also 28 degrees. Okay? So that's technically how the picture should be drawn. Okay? And we want to know what is the horizontal distance from the boat to the base of the lighthouse. So we want to know this. So when we look at 28, we're thinking opposite over adjacent. So tan 28 equals 150 over x. As long as you end up with tan 28 equals 150 over x, you're good. Right? So we get x equals 150 divided by tan 28. Just skipping that one step in the middle of x tan 28 equals 150. When we put that in the old calculadora, we get x equals 282.1 feet. All right, last one. We're going to do this one down here. Okay? You can try to draw the picture. It's not very easy to draw, but you can try. Scuba diver spots a shipwreck at an angle of depression of 26 degrees. The angle of elevation from the scuba diver to the boat is 53. Anybody been scuba diving? It's awesome, isn't it? Super cool. Where'd you go?
I've been in a couple places.
Okay. Turks and Caicos. That's where I did it. It was amazing. Where'd you go?
Mexico too.
Nice. Were you drift diving?
No.
Okay. Because they do drift dives a lot in Mexico because there's a lot of current. So you just kind of float along and you catch a boat like a mile away. And that would scare me. Okay. So we've got the water, right? The water's up here, right? So it's below the water, right? And they give us this distance, and that distance. So you're the scuba diver, you're underwater here, right? And you're looking down at a shipwreck, right? And your dive boat's up here above the water. Okay, so they tell us that this distance from this distance right here is 120 degrees. They tell us that when the scuba diver looks up at the boat, it's 53 degrees. Looks down here, it's 26 degrees. Okay, so we want to find, we'll say, from the middle scuba diver up to the boat is X, and from the scuba diver down to the shipwreck is Y, and then we'll solve. So we got tan 53 equals X over 120. For that equation, and tan 26 equals Y over 120. So it's 120 tan 53. That gives us our X value. And then 120 tan 26 gives us our Y value. Okay, when you solve those both, we get X equals 159.2 and Y gives us 58.5. And we want to know how far it is from the boat to the shipwreck. So I'm going to add those two numbers up. When I do that, I get 217.7. 120 tan 53. 159. So that's an expert scuba diver, right? Because when you get your first little dive, like you go to take all the classes and do your under open water tests, you can only go to 60 feet depth. So you have to get it more advanced to go to 100 feet, and they're 159 feet down, so they're like super advanced. Gets really cold the further down you go and dark. Okay, so 217.7 feet. Don't forget your units. You're doing 1 through 10 all, and we're going to do 13 and 14. I did 12 in first period, and 12 is weird. It doesn't work well. I'm gonna switch that. I will display answers up here. Remember, let me stop this video real quick.